right, guys, welcome back. We're almost done with this series. This is chapter 11 in our AP Computer Science A prep book. Today, we're talking about inheritance. So inheritance is really important for object-oriented programming. And we're gonna see why. It's gonna open up a lot of new design opportunities for you. Is this pointed in the right direction? Can you see this side of the board? Okay. All right. You can think of classes as a hierarchy, a tree. So we've talked about shape before, right? And we had a class for shape, and we had methods on shape and data for shape, and we did things with shapes. But shape is a very generic term, right? So really what you want to have is circle. You want to have square. You want to have triangle. Triangle. Okay? So here are very specific shapes that are children of shape. So shape is like the parent, and circle, square, and triangle are the children. Okay, and the idea is that they have similar behaviors that they inherit from the parent. Certain data that they're going to inherit from the parent. They might have some other data that is specific to them, like a circle is going to have a radius. None of the others have radius, right? But they're all going to have a color and a position. That's going to come from shape. That'll all be shared. Okay. Now, this is a very simple hierarchy. They can get more involved. Like you could say this is going to be a rectangle, and this is going to be a square. Because a square is just a rectangle with 4 equal sides, right? I mean, you can take this to extremes. You know, you could have, round objects like ovals and things like that, and you can have polygons and a rectangle and square, or polygons, triangles, polygon. You can take this to whatever extreme you want to for your design. But this is basically the idea. Okay, so in this idea, if we're talking about this, we could have, for example, an array list of shape x is equal to new array list. This is a lot of writing. Paren like that. Okay. So we make an array list of shape. And then you could say x dot add 0 new circle. Okay. Now remember in the last lecture I said you can only have the same type of things in an array list. Well, according to this diagram, a circle is a shape. In fact, that's what it's called. It's an is-a relationship. A circle is a shape in this design. So that's okay. We can put a circle in here. We can put a rectangle in there. We can put a triangle in there. Okay? And if we had a loop that, for example, iterated, I won't write all that out because we've seen that before, but if you iterate over this array list and say, I want to draw them all, boom, 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 you'd say something like, x dot get I, that's your iteration, dot draw. And it would draw all the shapes. Okay, so that's a really handy way of doing something consistently over a collection of things. And yet these things are different. They might even have subtle difference in behavior. Like, what do you have to do to draw a circle? Is it the same thing that you do to draw a rectangle? Probably not. Rectangle, you'd have four straight lines. Circle, you've got to have some fancy math to draw the actual circle. So the implementation of what it takes to draw the shape is completely different from a circle to a rectangle. But at this level, when we're thinking up here at shape just says you got to have something that draws yourself. That's it. How you do it, your problem. Okay, and then we're going to see how that works. Just the takeaway right here is This is a hierarchy, parents and children, and this relationship is called a has-a. I'm sorry, it's called an is-a relationship. It's an is-a. A square is a rectangle. Rectangle is a shape. Okay? That's why we call this inheritance, because you're inheriting stuff from your parents. Natural good looks. All right. There is a concept of multiple inheritance that Java doesn't support. In fact, almost no modern languages support. It was an early OO thing for reasons I won't go into. Is a terrible idea. And the idea is I have some child here and it has two parents. It inherits from both parents. I guess I'll say a little bit about why it's a bad idea. Remember I said you inherit stuff from your parents? Let's say you inherit, well, we talked about draw. Okay, so there's a draw method defined in P, and there's a draw method defined in P2, right? Now I'm inheriting all that stuff down to my child C, and C wants to go C dot draw. Which one does it use? Right? Who knows? You got to have some mechanism in your programming language to decide which one you're going to do. And that turns out to be really complicated and ugly in your code, and nobody wants to read that. So rather than make it nice, the computer science gods, whoever they are, decided, you know what, for most use, this is kind of dumb. We're just going to forbid this. So now it's very clear where draw comes from. I'm kind of lying. There are techniques that simulate multiple inheritance to a degree. We're not getting into those. It's a more advanced subject. Okay, is that clear? Do you understand what multiple inheritance is? Okay, great. Moving on. All right. Now, oh yeah, getting back to this, parent, child. Here's another term for you. In the book, they don't actually call it parent and child, although that's very common nomenclature. Another very the more correct way to say that is this is the superclass. This is the subclass. Okay, that's the term that you'll probably see in your test: superclass and subclass. You can think of it as parent and child, same thing. Okay, let's talk constructor. What does this actually look like? We've already seen, well, let's put it up here. Public class shape. We're gonna add some more stuff in here, we'll come back to that. Public class circle. Okay, before we go any farther, look what we did. This is new. Extends shape. This is how you link the parent with the superclass and the subclass. This extends word, and then the name of the class is the parent. Right? So now I've made this relationship between the two. Okay, so let's create a constructor here. We'll say public shape. It's empty for now. It may do some stuff, it may not. Okay. Constructor for circle. Okay. Now, so far these constructors are just simple empty constructors. They don't do anything. Down here though, I added this curious super business. What's that? Super is a keyword. It basically means call, when there's nothing else there, just super in the parentheses, call the constructor of the parent. that's always a good idea. So it's like, you don't know. Maybe you didn't even write this shape class, right? You might have gotten it from somewhere else. You don't know what it's doing when it's building itself. And so it's always a good idea to say, okay, I'm extending shape. So as I'm constructing a circle, and circle is a shape, before I've done, and it has to be the first thing you do, call super. Go construct a shape first. Because what Java is doing in memory, it's actually constructing both of these. It's constructing a shape and a circle. It's treating this all as one, as a circle. C-I-R-C-L-E, okay. But it's constructing both. And so here you're saying, go construct your daddy, then come back and construct me. Okay, now that I've said that, it's a good practice to always do that. But if you have empty constructors here with nothing else going on, it's okay to not have it. You can just, Java will be smart enough to know what it's supposed to do. But you absolutely have to have it if there are parameters involved. So let's say okay, just for fun, let's say a shape you must set an initial position. So you must, when you construct a shape, you have to give it some position. And remember when we had the whole thing written out, we had a data element for position. So we assign that, and as we construct the shape. Okay, that's required. Okay, so that means we have to do it down here. So we'd say super. Now here I'm passing just a hardwired value 5. So it's going to construct a shape with the position 5. Okay, but it doesn't have to be hardwired. It can be, but it can also be this. Don't do that. Okay, so here I've got a parameter that I'm just passing along to super. Okay, that's all it is. Now, I told you circles might be different than other shapes. They have a radius. So let's just say it also requires what happens here. Well, shapes don't have radiuses, circles do. So here I could say something like radius equals r. So in this case, what am I doing? I'm creating the shape. I'm creating daddy first, giving it whatever information it requires. Okay. And then I'm continuing on with the circle constructor, doing whatever I have to do to construct the circle. Okay, is this relationship with constructors clear? Okay. All right, good. So, now let's talk a little bit about method inheritance. What's that? Let's pretend the constructors are already there. I've only got so much board space. Let's say there is a public void move. We've seen this before, right? And it does stuff. All right, remember that one? Okay, so in the circle class, because this says public here, this method is automatically inherited by the subclass circle. It's there already. You don't have to put it in there again. It's already defined up here. It's already got actions. If these actions are fine for a circle, you're done, right? Now, but I mentioned earlier that all the other shapes that we had up there on the board were straight line shapes, so it's just points and lines. Okay, circles are different. So this move here probably isn't okay for a circle. So let's say this move method, when you wrote it, just assumed you're dealing with points and lines. Okay, well then that's not going to work here. But you have to have move, so what are you going to do? Well, you can do this. So I just wrote another move method here. You're saying, well, what's the big deal? It's exactly like this one. No, it's not. You can put different stuff in here. It doesn't have to do the same, in fact, it shouldn't do the same thing this one does. If you don't have it at all, you'll automatically get this one for free. But if you want it to be different, you give it the exact same signature, meaning public void move with the same parameters. That's important. And this is called this is not overloading. This is going to overwrite it. This is going to just eclipse the one that's already there. Okay, so yeah, it's overridden. You know, it's just clobbered this one, right? So if you have a circle C down here somewhere, and you have circle some variable that's a circle, and you say dot move 7, okay, it's going to call this one, not this one. Does that make sense? All right. So this is called method overriding. Overriding, you can think of it like you're overriding somebody, you're clobbering them. All right, there's another thing you can do with methods that's interesting. You can overload them. We kind of saw one of these, I think, before. Let's do this. Okay, look what I got here. I got another move method. The difference, though, is this takes a double and not an int. Okay, this is called overloading, where you have different flavors of the same thing. And you might provide this as a convenience. Maybe you kind of know how people might use this, and some people might have integers, some might have doubles for different usage. Okay, and it's convenient to use it the same way. That way, when you're using this, you can just have my circle C dot move 5, C dot move, 3.2, something like that. Okay. Now, there's two ways to handle this, though. If you actually want to do something different with a double than you do with an int, you can write all that code in here. Sometimes, though, it's just a converter. You do something like this dot move remember a few talks ago we talked about casting, where we put this in parentheses and you're saying take that double P and make it look like an int. Basically just chop the decimal point off. Okay, and then I'm calling this, which is this object right here, dot move with an integer. So I'm basically saying this double flavor of move is going to convert this to an integer and call the integer version. It's an adapter at that point. So it's up to you, the developer, whether you want to use it like an adapter, which is very common, or if there's actual different behavior that happens for these different data types. It's up to you. This is called method overloading. Okay, the other was method overriding, where you clobber it. This is where you have clones of different types, different flavors of the same method. Okay. All right. Book mentions abstract methods, but the test doesn't require that anymore, so we're not going to spend your time doing it here. I think we have one more concept to cover for this. Yes. Yeah. Polymorphism. We kind of touched on this. I didn't tell you what it was called. All right, so we'll write this out. Circle. Okay. polymorphism, if you think of the word poly, many, morphism, forms. So it's something that takes many forms. So here I've defined two children of shape. Oops, no I didn't, sorry. Extends shape. That's important. There you go. Okay, so two children of shape. Okay, and then we go back to that array list example. Stuff. Oops. Okay, so here we're making an array list of shape like we had before. Okay, so then I can say stuff add 0 new circle stuff add 1 new square. Okay, so create an array list of shape. I put a circle in there, put a square in there. They're both children of shape. That works, subclasses of shape. Okay, so what can I do with that? Well, I can have now a loop. I can say something like for I equals 0, I is less than 2, I plus plus, stuff dot get I dot move 3. Okay, so I want to move everything 3. Okay, well, think about that. I'm going to go through the stuff, but stuff isn't, it's the same thing, it's the same parent, but each individual object is actually different. I got a circle and I got a square, and I'm going to move it. Okay, now remember I showed you how you could have overridden method definitions. So move might be completely different for a circle and a square. Here it doesn't matter though, because up here in the shape class there's a move method defined. So there must be one in the children, or it will inherit the one that's there. Okay, so polymorphism basically is saying it's going to treat a circle and a square as if it was a shape, and just go ahead and move it. Does that make sense? Okay. All right, one other little detail here. And I think we'll be done with inheritance. And that has to do with this guy right here. Public versus private. Remember we have private things and public things? All right. Let me just expand maybe. I'll just talk about shape. Say private int pos 0. Protected, let's say int. Okay, there's a lot of writing on the board. What am I doing? I want to talk about public, protected, and private. The book doesn't talk about protected, but we're here, so I might as well talk about it. Okay, so these are all the methods, and these are data members. Now we know about private. It basically means nothing outside of the shape class can see pause, right? And then we said that's what we do. We hide the data, and we typically expose and make public the methods, right? So we've talked about this one and this one. Great. Now what happens when we inherit stuff? So here's, public class circle. Okay. What does circle inherit? Does it inherit pause from shape? No, it does not. It's private. It cannot see it. Okay, you cannot go in here. You can't say pause is equal to 17. You can do it anywhere up here, but you can't do it here in circle. It doesn't inherit there. Okay, now what about color? Color is using this new word, protected. What does that mean? Protected means you can use that thing in this class and any of its children, but nothing else. So if I'm over here, what do they call that in the other thing? A driver class or something? Some other class that combines things? You can't do, shape dot color. And say, nope, you can't access it. But your children, so down here in circle, I can say colors equal something. That's perfectly fine because it's part of the inheritance hierarchy. That's what protected does. Same thing for public, for the methods. I can call this, I can redefine it, no problem. And anything else out in your system that's not a shape, it can call a public method. A protected method, same as protected data. Something out here cannot call mult, whatever mult is, sometimes multiply. I just made that up. Whatever this is, out here in your system, you can't call this. The only thing that can call it is the shape class and any of its children. That's it, protected. Private, just like private data, means this is some utility function, some utility method that I've found convenient to break out into its own thing, and I can only call that in shape. I cannot see that in circle. So let's say I can do this though. Private void calc. I can do this. So here's another calc, and this is private. Even though it's named and these two look exactly the same, there's no relationship between the two. They're not inherited from one another. They're completely different. They just happen to look the same name and so forth. That's a bad idea, by the way, but perfectly fine from a compiler standpoint. But because they're both private, if I say something calc, that's it. Now, let's say I did something like this. Let's say here I have public void move again. Okay, and then down here in some other code, I want to call move. Now if I say something like this dot move, which move am I calling? This one. And in fact, you remember I told you this is often optional. If I just said move, it's going to call this one. For whatever reason, I'm making this up, right? But let's just say you want to force it to call this one. How do you think I'd do that? Super. Just like we had the super in the constructor, you can say super dot. There's no dot in the constructor, it's just super paren with any parameters in there. But if you say super dot some method, it's going to call the one that's defined in some class north of you. It could be your direct parent, actually it could be further up the tree. It's whatever the next available one is in the hierarchy, because remember, this could get sophisticated. You could have 3 or 4 levels up here. So it's just going to keep going up a level until it finds the next move. Okay? I think that's it for inheritance. So this one's probably as complicated as the class concept, class and object. These two things together work together. If you understand these, you have, the hardest parts of object-oriented programming down pat. Thank you.